Okay, here we have GeoGebra, and I created the triangle here that is kind of marked with the angles as well as the sides. And then I took 360, divided it by 5, 360 degrees in a full circle. I divided it by 5 and got 72. So I rotated the original down to this one, 72 degrees clockwise. I took this new one, rotated it clockwise, 72 degrees, rotated it again. So now I have these 5 triangles, and it kind of looks like maybe the blade's on a fan, but since GeoGebra is dynamic, I can take my original and move it. And so I could create a pentagon, 5-pointed star, just get these guys spinning like a fan, possibly. And notice the congruence. I have the blue circle at various points here. Those angles remain congruent. This side mark 2, 2, 2, 2. Those sides have remained congruent. So this was multiple rotations of 72 degrees, creating kind of this effect. And my original is not locked in. I can change that shape as well. The images I can't because they are dependent on the original. Here's my point of rotation, so I can actually move that around to create different versions of this. Okay, we're going to explore the transformations that we've been looking at, and first of all we're going to look at our original shape. It's movable, its points are movable, so we can change it around, and I'm going to first translate by a vector. Now the vector is really giving us our length, width, and our direction. So from E out to underneath F is a distance that it will move horizontally to the right, and from E up to F is the distance it will move vertically. And of course that vector can become left, right, up, or down. So it doesn't matter where the vector is, it is the horizontal and vertical distance determines the translation. So basically if I move this guy over and we look at this, I am now translating it to the right, all right, and up. Now I'm translating it to the right and down. If we want to look at the numerical values, I'm going to put this at 0, 0 so it's a little bit easier. This is a translation of 4 to the right and 2 up. This is a translation of 5 to the right and 1 down. This is a translation 3 to the left and 1 down. All right, 3 to the left and 1 up. And remember, our original shape was movable. Reflect in a line. Here's my line, and that determines the reflection. All right, now that could be the y-axis. Let me put these points right on the y-axis. That's one of the reflections we looked at. If I move and change that to the line of reflection to the x-axis, it came down here. The other one we looked at was when it goes through the line y equals x. Rotation clockwise 90 degrees. There it is at 90 degrees. Notice where it ends up. Notice the positions change a little bit. All right. Notice if I move it and rotate it 180 degrees, get that set at exactly 180 degrees, and also reflect the red one through the point. Ends up being at the same spot if that point is the origin. All right, so rotation around the origin of 180, reflection in a point gives us the same thing. So I'm going to turn the rotation off and reflecting through a point. Notice that position-wise what happens.